So the biggest and most exciting change is that you can now model SARS-CoV-2 or the novel coronavirus or COVID-19, whatever you prefer to call it. And since it's no longer modeling just the flu, we did change the name to Facility Infection Risk Estimator, and it now includes 2 different viruses and gives us the potential to add more in the future. You'll also see some additional inputs to include more technologies and behavioral trends, such as upper room UVGI, portable filter units, and mask wearing. These all contribute to the removal or inactivation strategies to reduce transmission. Now we know from different occurrences across the country and the world that there are super spreading incidences that can vastly impact how aggressively the virus spreads. For instance, a nursing home in Washington state had a super shedder move furniture in various rooms before ever showing symptoms, which then infected and ultimately killed dozens of people. So we've learned that it matters whether you're a light, medium, or heavy shedder of the virus, and the activity you're doing can greatly impact how many droplets and of what size you expel. So we've added varying activity levels to the tool, resting, light, moderate, and heavy for both children and adults, as well as 3 different levels of virus shedding, low, medium, and high. And we've added different expiratory means, breathing, speaking loudly or singing, coughing, and sneezing. These additions paint a more holistic picture of what we were actually seeing in the real world. You can also alter the number of sick days now, indicating how many work or school days people will miss when they get this virus. The default for influenza is 5 sick days lost per infection, and for SARS-CoV-2, it's 17. And this is based on a weighted average from 3 different studies. Inputs for air change rates for both outdoor and recirculated air have been changed to CFM per space rather than CFM per person. You can typically find these numbers on mechanical drawings, as-built, or construction documents to get a good sense of what the space was designed for. But we also recommend taking real measurements so that you can model what's actually happening in the space. And to do this, you may need an engineer's help. I think we know where to find some if you want a recommendation. There's a hypothetical R value that now estimates the single space examined relative to the amount of exposure time selected. Epidemiologists use this number to mathematically describe the spread of a disease. It's a ratio where the numerator is the total number of people who got infected, and the denominator is the number of people who were infected to begin with. So ideally, this is less than 1, meaning the virus is dying out. But if this number is more than 1, it means the virus is growing. More people are being infected than who started off being infected. In the space we're modeling, we want this to be less than 1 to know that less people are infected based on the indoor environmental conditions we are modeling. And finally, some figures and tables have been reconfigured for clarity. So we're going to jump into the tool and show you how to get to the tool and some basic walk through the inputs. Okay, so we are just at branchpattern.com. This is our homepage. If you click this menu circle in the top corner and under research, find the Facility Infection Risk Estimator version 2.0. Click that link and you will be brought to the tool itself. So pretty easy to get there. Before we walk through the inputs, I want to point out this user guide here. So if you open this up, you'll see an interactive table of contents that you can select to learn more about these various items. We have our disclaimer, some pretty robust descriptions of the inputs and calculations, as well as all the outputs. So if you get stuck or confused on what you should be putting in or how you can find that information, this guide is constantly being updated to help you navigate through the tool. There's also references with links to our sources and the weighted average salary sources for the US. So when we're measuring productivity loss, we typically need a salary amount to put to that. And you can find those weighted average salaries if you don't know off the top of your head. So if you scroll down, you'll see the tool here. There are 3 places to input information to then scroll down and find your results. So we'll walk through those quickly. You do need some room information and demographics. So we want to know the number of people under 18 and the number of people older, 18 or older, because adults and children spread the virus differently. And then we also want to know the activity level for both children and adults. So you'll see we have resting, light, moderate, and heavy. And if you're get a little confused or forget what I'm saying, you can always hover your mouse over these information bubbles to get more information on how to select the right thing. So for activity level, for example, we have resting being sitting, reading, sleeping, or watching TV. Light would be standing or most domestic or office work or probably classroom work. Moderate would be climbing the stairs or light exercise, and heavy would be vigorous exercise. So in a K through 12 setting, for example, maybe you're using light for a classroom and then heavy for a gymnasium. Here's where you input the weighted average salary, room height and area, which gives us volume. If you do have UVGI, we need to know the mounting height, and then the number of rooms in the building, if most rooms are similar. Again, like a classroom, maybe you have 15 classrooms in a building. Finally, we have viral parameters is next. We select the virus type, which now you can toggle between influenza and SARS-CoV-2. We have removal time, which is the amount of time after the expulsion incident and how we're measuring removal efficiencies. So with it being set at 0.250, we're measuring 15 minutes after the incident of expulsion. This is exposure time per day. This has a big impact, how long you're in the room. So maybe for an office, it's 8 hours, maybe for a classroom, it's 6, maybe for a gym, it's 1. So definitely we want you to play around with this exposure time to see how that impacts transmission rates. We have exposure time per viral season. This number we recommend being closer to 1%. This is really what percentage of the entire viral season are you actually exposed in this space. So accounting for every hour and every day and every week and every month. So 1% is probably a better number, but you can go up as high as 5%, probably not higher than that. Sick days lost per infection, you can change this number, but the average for SARS-CoV-2 is 17, and for influenza, it's 5. Number of infected people. So, typically we're modeling 1 infected person is coming into the space, but we have modeled a few scenarios where it's more realistic that maybe 2 people would come into the space infected. For example, a church where maybe a husband and wife are coming in together and they're both infected and don't know it yet. Maybe for a larger space like an airport terminal, you're modeling 3 people or 5 people that are coming in infected. So you can definitely change this. For most of the case studies we'll look at today, it'll be 1. Expiratory means, so we have breathing, speaking loudly, singing, coughing, and sneezing. Level of virus shedding, low, medium, and high. For most of the case studies, we'll look at medium. But if you want to see what would happen if a super shedder came into your space, you can model high and see how that changes things. And then we have vaccination rates. This is obviously 0 for SARS-CoV-2. For influenza, there are averages here through this information bubble to remind yourself, and these are based off of the last 9 years of CDC data for vaccination rates. So we have 57% for children and 42% for adults. Okay, and then lastly, we have our baseline and design conditions for the actual space that you're modeling. And this is similar to an energy model where you're going to be looking at a baseline compared to design. So when you're looking at your actual building, your baseline could be what the actual building is right now. And now you're playing with design conditions to see how to reduce transmission. The baseline could be a building built to code. And now you're showing how implementing certain strategies, you're reducing transmission rates more from code. Or maybe you already made some changes to your building and you want to show the community the impact those changes have had on transmission rates. So your baseline could be what your building was like operating back in February, and now your design is what it's operating like now, to show people actual numbers around the decisions you've made for different strategies. So you need some information here, the baseline relative humidity. Probably in the lowest winter extreme would be the best for modeling. So kind of the lowest relative humidity that you would see in your building. Baseline outdoor air and baseline recirculated air. And again, this is measured by CFM per space, which we will actually discuss more in detail how to find that information. But again, modeling what is actually happening is better than what it was designed to do. Then we have filter type here. We're 4 all the way to a HEPA filter, so you can experiment with different filtration levels. The UV-GI information for irradiance we need, and then we've added portable air cleaning units. So you just put in the number of portable air cleaning units. And then we do need to know the clean air delivery rate, which is measured in CFM. That is available through manufacturer data. If your portable air cleaning unit does not have this number, it's probably not working very well because it's not showing you how much clean air it's delivering. So definitely be sure to ask for this number from the manufacturer. And then we've added mask wearing. So you can model no mask and then various types of masks. So cotton quilt, this would be one that maybe your neighbor sewed for you. If you've bought one online recently, it's probably more like one of these two. Or we have surgical and N95 masks. So depending on the scenario you're modeling, you know your occupants best. What are they wearing? What are you seeing them wear? And then you put in those exact same conditions for the design of the building. And then as you scroll down and, as you're entering numbers, and we'll see this in the case study, these graphs start populating with your results. And the last thing I want to show you before I hand it back to Marcel is saving results as PDF. Once you've put in some things and you're ready to save and you want to show people, you can just click this button and save as a PDF here and save each variation that you're doing. So you don't have to remember the results off the top of your head anymore.